Hello, this is Mr. Gilmore with the 8.8, and in my best country voice, it ain't right what you're doing lesson. So, what we're going to explore in this last lesson is we've seen triangles that have been right this entire time. We've explored our trigonometry and what we can find within the relationships of the angles and the side ratios within right triangles. So, the question then is raised, what if our triangle is not right? Let's continue just talking about the right triangles for a few more moments before we start talking about these triangles that ain't right. Now, in a right triangle, we can do what's called solving a triangle. We've talked about this on previous homework assignments. Solving a triangle just simply means finding all the missing measures that are related to that given triangle using the given angle measures that you have. Well, in this right triangle, we're given one of our acute angle measures, and we're given a side measure of our right triangle. And what we can do with this right triangle then is solve it. We can fill in the other missing angle measures, and we can also fill in the side measures. Now, our triangle is blue because what I want to show you is that the angle measures, whenever you see a blue triangle like this, the angle measures are drawn to scale. So that actually is a 53-degree angle. We're going to see that this continues on with some of the other examples and also leading us into the worksheet. So what we're going to do is solve this right triangle, meaning let's find all the missing measures. That means measures of either angles or sides. Well, we can find our other missing acute angle measure very quickly by using Tasty. We then have an angle measure of 37 degrees tucked in corner for angle A. Now the goal is to find our missing side measures, side A and side B here. Well, there's several different approaches we can use. I'm going to go ahead and stick with the given 53-degree angle that we have, and I'm going to set up some trig ratios to then help solve for those two missing sides. Let's start with side A. So I'm going to use cosine. Cosine of our angle B, which is our 53 degrees, is equal to the adjacent side, which is side A, leg A, over the hypotenuse, which is 27. What we can then do is multiply both sides by 27 and solve for A. So really what I'm doing is 27 times the cosine of 53. Now remember, the cosine of 53 is really just a ratio. So what that's going to spit out is it's going to spit out that ratio value. So cosine of 53 degrees is 0.6018. We're going to multiply the 27 by our value there, and we are going to approximate this now. So I'm going to say approximately A is 16.2486. And there is our missing side for our A value. Now let's find our B value. In this case, I'm going to go ahead and use sine. So I have the sine of our 53 degrees is equal to the opposite side, which is B, over our hypotenuse, which is 27. What we can then do now is multiply both sides by 27. We get B is equal to 27 times the sine of 53 degrees. Now again, with our trig function there, the sine 53 degrees is really just a ratio number. So it's really 27 times the ratio that sine 53 spits out, which is 0.7986. Multiplying those two numbers together, and again, I'm going to use my approximation symbol here, that B is approximately 21.5622 in length. So that's what it looks like to solve a right triangle. If we are given a side and an angle, we can then get missing sides and we can find our missing acute angle. Another thing that we've seen with right triangles is solving for a missing angle measure. So in this case, if we were to solve this right triangle, we are given the side of 27, a side of 24, and we're looking then for our missing acute angle measures. Now, first of all, we also are missing a third side of our triangle, but we could find that with Pythagorean theorem. Let's go ahead and do that. So with Pythagorean theorem, we can actually solve for our missing side B. So I have 24 squared plus B squared is equal to 27 squared. And let's see, 24 squared is 576 plus B squared. 27 squared is 729. Subtract our 576 on both sides. We get B squared is equal to 153. Take the square root of both sides. Now, the square root of 153 has a perfect square of 9 in it. So there is then the 3 that pops out. Square root of 9 is 3, and 9, it's 9 times 17. So there we actually have our missing um, we have our simplified missing side of our right triangle there. But we can also find our missing acute angle measures. For example, I can solve for the missing angle A and the missing angle B. Let's find the missing angle A. Now, the missing angle A, I'm going to use the two sides that were given, which means for A, the two sides that are given are the opposite side and the hypotenuse, which means I'm going to be using the inverse sine function to then take the inverse of the ratio of the opposite over the hypotenuse. So that would be the 24 over 27. I'm going to go ahead and use a calculator in this case. It's a little bit trickier to find the right ratio on your table and then work backward. So I'm going to use a calculator and put that in. I am going to round this, so approximately 62.734 there we go, degrees. And that's our missing value of angle B. Now angle A. Now let's look for our missing value of angle B. And now for angle B, again, I'm going to use the two sides that are given, 24 and 27, which means it's the adjacent side to angle B and the hypotenuse. So I'm going to use the inverse cosine of actually that same ratio we saw earlier, 24 over 27. Popping that into our calculator. Again, calculator is going to work better in this case. It's a little hard to find those ratios on the trig table. B is then approximately equal to 27.266 degrees. And there we have it. Okay, there we have it. So we can solve a right triangle if we're given an angle measure and a side measure, or if we're given two sides of a right triangle, we can solve this triangle. But now the real question, what are we going to do with this critter, right? Take a look at this guy. This is not a right triangle, right? This is not a right triangle. And it really ain't right. So what's the strategy then if I were to ask you to solve this triangle, meaning find all the missing angle and side measures? What would you do? How would you tackle this? So obviously you jump in and go, okay, well, I can find the missing third angle. That's pretty easy. That would have to be 33 degrees, right? We got that one down pat. Okay. But what if I asked you to find the missing side A and the missing side B? Now things get a little trickier, don't they? Well, let's talk about a strategy that we actually have, a tool we have in our toolbox that will allow us to tackle this. Because, simply put, with it not being a right triangle, we don't have access to our sine, cosine, tangent functions because they were defined by using a right triangle. Well, with the triangle not being right, how are we supposed to use those relationships of sine, cosine, tangent to find these missing side measures? We have a tool, and that tool is in altitude. In altitude, when dropped in, we form right triangles. And because of that, we can use that altitude as a reason then to tap into our sine, cosine, and tangent functions. Now, the specific triangle case we're given is an angle side case. So notice that we're given the case is an angle side case. We're going to explore the other cases on the worksheet, and actually in class we'll walk through some of the other cases examples together because they can get a little tricky. So with the angle side case in this example, what we're going to do is we are going to drop an altitude, but not anywhere. We want a strategic altitude, and where we're going to actually drop this altitude is from vertex C. So I'm going to produce this altitude to our opposite side here, AB. And that altitude then is going to cut our angle 103 up into two smaller angles. Using TACE, we can find that this side of our angle is 46 degrees and the other side is 57 degrees, okay, because the total is still 103 degrees. So now we have these right triangles involved. We can tap into sine, cosine, tangent. But here's the issue. In order for us to find the missing side measures, we need an acute angle measure and one of the sides. But notice that where our altitude drops in and connects to our side AB, that means it cuts our side 27 into two smaller segments. But we have to find those two smaller segments. And this is where it gets a little bit So I would say the algebraic tedious work jumps into play. I'm going to walk you through this scenario, showing you strategically where and how to find these missing segment measures from A. We'll call this point here Z. So from A to Z and from B to Z, what are those missing links? Well, if you're ever chopping a segment into two smaller parts, it's always appropriate then to assign one of those two smaller parts a variable. So I'm going to call this segment here from B to Z a length of x. What then can I say about the length from A to Z? I can then call that length 27 minus x. So I know the whole length is 27, right? I'll just go ahead and mark that. The whole length is 27. But the two smaller segments then, I've labeled one as x and the other is 27 minus x. The key then is if I can find out what that measure of x is, then I know those two lengths of the triangle, which then give me the opportunity to find our missing sides A and B. So the first trick is find the missing value of x. How? Well, we have access to our sine, cosine, and tangent functions. And the way we're going to actually relate these together to find our missing value of x is using that altitude we dropped in. I'm going to call that altitude h. Now follow along with me. Here's where I begin. Let's start with the 33-degree angle with angle A. There's a relationship that that angle has with the opposite side, h, and its adjacent side, which contains our variable x, 27 minus x. So here's what our first equation looks like. Tangent of 33 is equal to the opposite side, h, over the adjacent side, 27 minus x. Well, I can actually solve that equation to get h by itself. So I'm going to cross multiply it here. Actually, multiply both sides by 27 minus x. What that looks like is I'm going to leave this in parentheses. I get 27 minus x times the tangent of 33. Now remember, the tangent of 33 is really just a number. We'll plug that number in here just a little bit. But I have another relation to our side h. That's from the 44-degree angle. So watch what I do here. I then do the tangent of the 44-degree angle is equal to the opposite over its adjacent side, which is x. What you should notice here is that there are two equations and two variables. We can solve for a missing variable. What I'm going to do is multiply both sides by x. So I get x times the tangent of 44 is equal to h. Now notice that both of these equations are equal to h. So I can bring these two expressions together and set them equal. So I get 27 minus x times the tangent of 33 is equal to x times the tangent of 44. Hey, that's one variable, one equation. We can solve for x. First thing I'm going to do is replace our tangents of 33 and tangent of 44 with their respective values of the ratio. And so I've got this. I'm going to actually bring that number out front of tangent of 33. So the tangent of 33 is 0.6494, and that's being multiplied to this 27 minus x. And this tangent of 44 is 0.9657. Again, I brought that out front, and that's attached to x. This is going to make it a little easier now to solve this. So I'm going to distribute the 0.6494 through. So I multiply that to 27, which spits out then 5338 minus this 0.6494x is equal to 0.9657x. Okay, well, I'm then going to get my like terms together. So I'm going to add the 0.6494x to both sides. I'm going to flip my equation around. I get 1.6151x is equal to 17.5338. And there we have it. Divide both sides by our 1.6151. And what we get is x is approximately equal to 10.8562. Now that changes the whole dynamic of our problem. I can come over here for where my x value was and go, oh, that x value, I know what that is now. It is just simply 10.8562, or roughly that. What I can then do is take 27 minus x, and I get then approximately 16.1438. With these two values, that completes the in each right triangle a side, and I have an acute angle measure. So I can solve for the missing side A and the missing side B. Let's actually solve for the missing side A first. So I'm going to use our 44-degree angle here, and the adjacent side it is to it, the 10.8562, with the then A being the hypotenuse of that right triangle. We're going to use then cosine. So the adjacent over the hypotenuse. So the cosine, let's see, I'll make some room. I'll just section that off right there. So we have the cosine of 44 degrees is equal to the adjacent side, 10.8562, divided by the hypotenuse A. Now, remember this algebraic trick? You can just swap those two guys. You get alpha, or sorry, A is roughly equal, well, that's right. A is equal to this 10.8562. Now, I'm going to go ahead and plug in what cosine of 44 is. That is 0.7193. And simplifying that, we get our missing side measure for side A as roughly 15.0927. And look at that. We found our missing side length with using our primary tool of an altitude. Now let's solve for our missing side B. I'm going to use the cosine of 33 because the cosine of 33, I have my adjacent side now and my hypotenuse, which is B. I can then solve for our missing side B. So the cosine of 33 is equal to the adjacent 16.1438 divided by the hypotenuse B. I again do that algebraic trick, switch those, and I get B is equal to 16.1438. That is divided by the cosine of 33, which I'm going to go ahead and plug in its respective ratio, which is 0.8387. Divide that out, we get a side measure of B roughly to be 19.2486. And there we have it, folks. Look at that. We have successfully solved this non-right triangle ABC by using the power of the altitude. Now, once I said this already, this is an angle side case. You're going to run into the side angle side case, the angle side angle case, and also the side case. In each one of those cases, we have to tackle a little bit differently. However, the strategy remains the same: drop in an altitude. And we'll talk more about how to solve those in class. So please be sure to hop over to the worksheet on the 8.8 worksheet and be working on solving these non-right triangles. If you do have any questions on this about where to drop that altitude in or where to even begin algebraically, please do not hesitate to email me. I know that the algebra can get a little bit tedious, especially when you're trying to find some of the missing side measures. It can get a little daunting. However, with some practice, you'll get the hang of it. So we're at the end of our lesson. Please be good and do good.